Hey, slackers. This is video lesson 19. I can't even believe it, but it is. Welcome back. I'm attempting to record at about 8 in the morning on Monday. So my family is all sleeping. I got up like I was getting up for work today. I felt kind of human and a little bit of normal. Maybe I should try this more often. I did it a couple of times and then it got washed down the drain. I'm fully expecting Olivia at the least to wake up any second, my 7-year-old, and come running out and jump into the camera here. So let me explain my ridiculous pen. Everybody see my ridiculous pen? I love my ridiculous pen. Let me explain why. So my favorite flower in the world is a rose. And I absolutely love, in fact, yellow roses are my favorite. But for Mother's Day, my little thoughtful 7-year-old had Jimmy order a pack of 20 of these. They're adorable. So I promised her next time I was teaching I would use my ridiculous pen. You guys all know how I love ridiculous things. So obviously my 7-year-old now knows that too. So hashtag warning, she's gonna come out, she's gonna run in, and then she's gonna be like, oh my God, you're using my pen, la, 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 la. So just be prepared. And then also over here, you see this blackness right here that I'm touching? Right there, that's my giant black cat who, because none of the kids are awake, is all over me. And he kept, while I was teaching calculus before, see him, he's moving around. He was like coming into the video. I had to keep putting him to the side. He was trying to rub my face. I'm like, oh my God, this is ridiculous. No matter what I do. I can get up at 6 in the morning, try and teach, my animals are needy. Try and teach during the day, my kids and my husband are needy. Try to teach at night, my husband's needy. I'm like, oh my God, I can't get away. But anyway, hope you're all doing well, despite my madness. So we are gonna continue with, yes, probability. No, I'm so over it. I'm thinking video lesson 19 and 20, we'll finish up probability and probably start doing like a review and quiz and close the book on it because I'm so over it. I know you guys are too. So this is notes for video lesson 19, believe it or not. Okay, I'm gonna start out going over the homework from 204 to 206. So that is this right here. And I believe you had to do 13 through 15, right? All parts. So we're looking at 13, 14, and 15. All right, so let's take a look at these and then we'll move on to the last notes packet of probability. Okay, so for 13, young adult residences. According to the Bureau of the Census, the following statistics describe the number in thousands of young adults living at home or in a dormitory in the year 2004. Dormitory is a dorm, and that's talking about living on campus in college. So we have males, ages 18 to 24, and females, ages 25 to 34, living in a dorm. And yeah, this happens. I know this looks weird, but you do have people 25 to 34 living in dorms on campus. I know some of you are like, that's really weird. It is and it isn't. It kind of depends on what school you go to, especially if it's a university and it's a larger university and they offer like the medical program. You have kids or people who have done their undergrad, their graduate, and are now doing their PhD in this age range and are still just taking out massive loans and living on campus. Some of them are on scholarships. So in order to accept your free ride or your scholarship, you have to live on campus. So it's not as weird as you think. It's just not as common, but not as weird as you think, okay? All right, this is real data, it's sourced. So it says choose one student at random and find the probability that the student is. Okay, in order to do this, I have to find out the total first, right? So I'm gonna add up all these numbers. Okay, I'm getting 17,230 as a total. All right, so over here for number 13, and this is for the text pages 204 to 206. Okay, it's just so for part A, I want the probability of a female 25 to 34. female, that's 25 to 34. So that's literally one section of them, the 995 out of my total, 17,230. The question is, can I reduce that? That's about 6%. It does reduce, 199 over 3446. Okay, that's about 6%. Good morning. Now I expect you to wake up first. How you doing?
Good.
All right, so part B. We have the probability of a male, and it says or, it's gonna get a little tricky here, aged 18 to 24. Now they're saying, you gotta be careful here. They want all males, doesn't matter what age group, and they want all people, doesn't matter what gender on this side. So we have to be careful of overlapping. Okay, so if we look at males first, all males is 7922 and 2534. All right, so we have this number over the total, 10,456 over 17,230. Or means we add. Now be careful here. They want males and females in this age group. Okay, so take a look. First thing I did is all males. So I added up 7922 and 2534. Now they want everybody 18 to 24. That would be these two numbers, but, and it's a big but, we already did these numbers, 7922. So I can't count them twice, otherwise I'm adding an additional 7,922 males to my total of 17,230, would inflate the number ridiculously. So I'm only gonna do the 5779. You know who that is, right? No. I would say that's Olivia, put that up there. That's an Olivia spot. My husband just found one of the remotes for the TV, like the actual TV remote, which we couldn't find, which is so annoying because it's like the age-old thing in this house. Okay, so we have 10,456 plus those females, 18 to 24. We have 16,235 divided by the total. Now I'm just going to make sure that that doesn't reduce. As a percent, it looks like it's 94%, which is pretty much makes sense. Most people living in a college dorm are going to be ages 18 to 24. I know you're like, but people graduate at 22. No, they don't. They change the average person changes their major. Over 85% of people change their major 3 times before they graduate, which causes them to graduate later. Okay? So majority of people living in a dorm, 94% of them, that makes sense. They're going to be between 18 and 24. But it's not so weird to have somebody who's 26, 27 in the PhD program or medical program or whatever that's going to be living in a dorm. So it's 94%. Let's see if it reduces. It does. 3247 over 3446 or 94%. I don't care which answer you give me. All right, and part C. We have under 25 years of age. So they're less than 25 years old, or, and not a male. Ooh, baby. So they have to be less than 25 and not a male. I'm going to do this one literally. If they're less than 25, you're looking at this age group, 18 to 24. And if they're not a male, then it's the less than 25-year-olds that are what? That's right, female. So it's 5779 out of the total. And if I put that in, it's about 36%. Whoa, did not mean to do that. It's shooting out the same answer, so that's in lowest terms. So we're going to say it's about 34%. 33.5 or 34%. Okay? Which means that in this case, where they collected the data in the year 2004, most of the people who dormed under the age of 25 are not females. They're what? Males. Because only 34% of them are females. So slim pickings, gentlemen. Slim pickings that year. Okay, anyway, I'm just kidding. That's terrible, right? Okay, let's keep going. Let's look at 14. For 14, we have endangered species. Another weird little graph chart thingy-majiggy going on. So you have the chart below shows the numbers of endangered and threatened species both here in the United States and abroad. What's the difference between endangered and threatened? What do you think? Endangered means technically they're almost extinct. Okay, so they're endangered. They're those are the ones that if they capture them and they're animals globally or around the world that can be hunted, they try to put them in zoos right away. And I know there's a lot of controversy behind having an animal in a zoo versus not having an animal in a zoo. But usually if it's an endangered species, they try to put them in a zoo because at least they know they're keeping the species safe. So they try to get a male, they try to get a female, and obviously biology, they hope that it's going to reproduce. They'll be happy enough to reproduce, especially in a zoo. That's really important to make sure that they're happy. They will not reproduce if they're not happy in their environment. So they try to get a male and a female together to reproduce so that they could try to save the species, so to say. A threatened species means that statistically speaking, it's very close to being endangered. So they watch it. What is the biggest animal right now in the year 2020 that they're being very careful about with this? Endangered and threatened. They're threatened. They're worried about him being endangered. Anybody know? I'm pretty sure, believe it or not, it's the elephant. Isn't it the elephant, Jimmy? That's the big one that they just changed the law a year ago and they're allowing people to hunt elephants in certain parts of the world. Wasn't that like a big deal?
I heard something about that.
I'm pretty sure it's elephants. I'm going to double check that because if I remember correctly, I hate to say it, but it is the truth. And I'm not getting political with this. Trump's son hunts and they had a picture of him hunting an elephant. There's another one too. It's the elephant and I want to say the cheetah or something like that. So I'm going to look that up for you guys for next time. But those are the two big ones that in the last year and a half, they changed the laws. Prior to that, you were not allowed to hunt them anymore because they were becoming threatened species. They changed the law and they're allowing them to hunt them anyway now, which is terrible. It's terrible. I don't know about you guys. I'm very intrigued by certain species of animals. Dolphins. I love dolphins. It's like my dream to swim with dolphins. We were going to when we were in Mexico and we just didn't get to it. It was going to be my birthday gift. We were going to leave the resort in Cabo and I was going to swim with the dolphins because it's like one of my bucket list things. But I did not get a chance to do that technically. So Jimmy owes me on that one. We're supposed to hopefully go back to Cabo for my 40th and I am swimming with dolphins. I am going to swim with dolphins. So I love dolphins. I think they're amazingly intelligent and beautiful and sweet. But I also I have an affinity for elephants. I think elephants are brilliant. They're so similar to us. They're so sweet with their young and as a family, how they stick together. I think it's very cute. So whatever, that's just Sakaro being Sakaro and sharing useless information with you. Okay, so anyway, here we go. We have the United States and abroad. This is real data. It's sourced. So choose one species at random and find the probability that it is threatened and in the United States. So this is a little wiggity whack. We have to actually find the total of all of these first. You ready? So here we go. 68 plus 77 plus 14 plus 11 plus your mom and your dad and your sister and your brother, maybe stepsister, maybe half brother, keeping it in the family, grandma, pops. Okay, I'll shut up now. Okay, there's 766 all together, okay? So for number 14, they want the probability that it's threatened and the probability that it's in the US. So literally, we're looking here and we're gonna say threatened is this side and only the United States are all of these numbers here. Threatened and the United States has to be all these guys. So 10 plus 13 plus 22 plus 10 is 55 over 766. Now, I'm just going to make sure that that doesn't reduce. It shouldn't, but it might. It looks like it's about 7%, and it does not reduce. So you can either tell me it's 7% or 55 over 76. All right, part B. We're going to have endangered foreign bird. Endangered, and it has to be a foreign bird. I had to teach my daughter last week about birds. We're doing animal studies. Birds, birds, birds. Guys, I would much rather teach college statistics than first grade, but anyway. Endangered foreign birds. So we're going to look on the endangered side, and we're looking at foreign birds, which is just this number right here, 175. Come back. Over 766. And that looks like it's 23%, and it does not reduce. All right, and last but not least, we have a mammal or a threatened foreign species. Mammal or threatened foreign. Okay, so the probability of a mammal, or all of these, they say in general, all four. So 68 plus 251 plus 10 plus 20. We get something like 349 out of 766. Or means we're going to add. Now we have to be careful of overlapping. They want a threatened foreign species. Threatened foreign are these four. But, it's a big but, you can't count this 20 twice. So we're just going to do 6, 16, and 1. Shut up, it's my joke. I say but it's a big but. How gross is he? He hears the word but and he's interested all of a sudden. Okay, so 349 plus 23 is 372. All right, and if I see if that reduces, it's about 49%. It does reduce. 186 over 383 would be the number you would technically want to give, or about 49%. All right, and one more. We have number 15. Isn't this so much fun? I hate probability. Okay, so, this one's kind of interesting. It's not sourced, but usually when I do this problem, I go into a whole big rant about births. Okay, so let's take a look. You're like, births, yay, thanks from the pregnant lady. Okay, multiple births. The number of multiple births in the United States for a recent year indicated that there were 128,665 sets of twins, 7,110 triplets, and 468 sets of quadruplets. And yes, ladies and gentlemen, 85 sets of quintuplets. Whoa, buddy. These triplets are 3. Quadruplets are 4, and quintuplets are 5. 5 babies at once. I actually have a friend from high school that completely genetically had a set of triplets. Identical triplet boys. Kind of a funny story. She had her first baby. It was a boy. Okay? He got to be close to 2 years old. Her and her husband were like, okay, let's try and have another baby. The kids will be 2-3 years apart. We want another sibling, blah, blah, blah. She went to go get pregnant with her husband, totally naturally. No drugs, no infertility, no nothing. Go in. She finds out she's pregnant. She goes to the doctor. Her husband's with her. They do the sonogram. They're like, it's very funny the way her husband described it. This is baby A's heartbeat. This is baby B's heartbeat. And this is baby C. Her husband passed out apparently in the appointment. Like he just passed out on the floor, like completely dropped dead in the middle of the sonogram appointment. They woke him up, whatever, he came to pretty quickly. And he was like, tell me that just didn't happen. And she was like, yeah, it did happen. Then she finds out it's 3 identical boys. So she ended up having 4 boys under the age of 3. 10 months later, all in diapers. So I can't even imagine. When she was like 6 months pregnant, because it was triplets, the doctors said, like, be prepared, you can go into labor because it's triplets. And like, when you have that many babies, you don't usually carry full term, which is 36 weeks. Usually you go early. Statistically, it's a very high chance. So they had to have everything ready, like, super early. They had to get a stroller for 4 kids, 4, and like a car to fit 4 car seats, like, just insanity. So it was very funny. She would like post on social media, like, the stroller, and it was like side by side, but like staggered. It was wild. And the husband had to like put it together, and they like posted the picture, and they were like, the husband like put it up, and he was like, yeah, poop just got real in our life. Like, I put this thing together, and my wife and I just sat on the couch and started crying because they're like, how are we gonna have 4 kids at once? Yeah, so anyway, why am I bringing this up? That happened naturally. That was genes. That was his genes and her genes got together. Somewhere in their family, they have twins. They have some sort of multiple birth gene that she had triplets, identical triplets, which is an even weirder statistic that they're identical. Usually when you have a multiple birth and it goes over twins, like triplets, quadruplets, quintuplets, sextuplets, I think they're actually called sextuplets. I don't know. The chance of them being identical gets really, really small really quick. So it's wild that happened to her. What I want you guys to realize is, in this country particularly, the statistic for multiple births has gone up tremendously in the last 10 years. I want you to try and think about why. Why is the statistic for multiple births? Why are more people in the last 10 years are having twins, triplets, quadruplets, quintuplets? It's happening more now than ever before in the last decade. And the statistic has gone up drastically. Like, what is that? More people who come from twins and triplets are getting together with other people who have twins and triplets, so the chances are going up? No, that's not it. That's not it. What do you think? It's because of infertility. The use of infertility drugs to conceive and have a baby has gone up drastically. Why? Why are more people seeking help to get pregnant now more than ever in the last 10 years? What do you think has affected that statistic? Because this is all very true in the country. All right, well, I'll give you a hint. The average age of a woman trying to have a baby has gone up. So why would that change it? Well, think about it. Like, my parents and Jimmy's parents, they're a weird statistic. They actually waited a while to have kids. Most people in their generation, they went to high school, got married at like 18, 19 years old, and started a family right away. The mom stayed home. By the time they were 20, 21 years old, they already had a kid or two. They were already popping kids out. Like, that's just how it was in the 60s and the 50s and in the 60s and 70s. What changed was, like, my parents waited till they were like in their mid 20s, which was weird for them. They were like real hippies. They weren't going to have kids. The world was too messed up to have children. They like bought a van and finished it, went cross country for like a year. They're like nuts. And then they started having kids. So they had kids much later. I'm pretty sure your family did too, right, Jim? Didn't your parents actually wait a long time for their generation?
Well, I mean, they didn't get married till a little later, and then they had a,
Yeah, they got married later. My parents were married young. My mom was 19 when she got married, which seems weird to us even now. So yeah, people get married later. People have children later because women are now not staying at home and just being a mother and a wife. They're going to college. They're having careers. They're establishing themselves. And then when they're like 30, like me, or 35, in that age range, they're like, okay, let's start a family. So the whole age difference has affected that statistic. And now you have women who are older who are trying to conceive. So, which makes it harder because your eggs are as old as a woman. So if you're 35, your eggs are 35 years old. And I've shared this with you guys that 35 and over is considered what you would call a geriatric pregnancy. I am a geriatric pregnancy. It puts you at high risk because your eggs are older. The statistic of the baby being born with chromosomal disorders goes up immediately. There's a higher chance of Down syndrome. mental retardation, all kinds of things. And that's directly attached to the age of 35. So if you have more women, statistically speaking, over the last 10 years having babies at that age, they're struggling. They can't get pregnant as easily. So then they seek infertility. They go through in vitro, they go through all kinds of things. They take drugs, they take hormones to try and get pregnant. Once you start down that path where you're putting hormones in your body to have a baby, that's where these numbers go up exponentially. So the friend I told you about, though, they were not on anything. That happened completely naturally, which is crazy. So anyway, just a little thing, a little tidbit. I usually in class would give you the actual statistics, or for homework tell you as like a bonus. You could look it up and tell me what the actual statistic is and compare it to 10 years ago, because it's mind-blowing when you look at like what is the statistic for having twins and triplets now compared to 10 years ago. And you can actually separate the data and it'll tell you with infertility and without. And it's like, oh my God, it's staggering difference. It's crazy. Okay, so it says, choose one set of siblings at random, find the probability that it represented more than 2 babies. More than 2 babies means 3 babies, 4 babies, or 5 babies. So first thing I have to do is add up all these babies. Babies everywhere. I feel like some of you right now would go, Mr. Carol, have you thought of a name yet? I know some of you are laughing because you're literally thinking that. Isn't that weird that I know you that well? Okay, 136,328 total babies in this problem. So if we're talking more than 2, that's the 7110 plus 468 plus 85. There it is. So 7663. So the probability that it's greater than 2 kids is 7,663 out of the total 136,328. All right, part B. Represented quads or quints, 4 or 5 kids. And that is 468 plus 85 is 553 out of 136. Oh, look at me, I got lazy. I didn't see if it could reduce. Bad math teacher. That's about 6% to have more than twins. It's about a 6% chance, okay? Let's see if that reduces. No, it doesn't. So I would say this, or 6%. And then this number over here, 553 out of 136, 328, is a less than 1% chance. It's a 0.4% chance. There's a 0.4% chance of having 4 or 5 children at once. Oh my God, I can't even imagine. I can't. 4 or 5 kids at once? I think I would just die right there. Okay, now choose one baby from multiple births. What is the probability that the baby was a triplet? A triplet is just 7,110 out of the total. Okay, let's see what that is. Oh, there's Ophelia. 5%. I'm sorry, babe. It does not reduce. So, kind of interesting if you look at this data. You have a bigger chance of having a baby, of having a multiple birth, triplet, quadruplet, quintuplets, than you do just having triplets. Holy crap, that's scary. Okay, so anyway, that wraps that up. Let's go over here to the new notes packet. Yes, yes? Let's move on in life. How do we feel about that? I feel kind of good about it. I'm closing the book on this. I'm kind of over just basic probability with you guys at this point with ends and ors and knots and all that jazz. All right, so here we go. New notes packet. Now here comes my 2-year-old, so get ready. I really thought Olivia would wake up first. She's sleeping late this morning. All right, so here we go. So here we are. All right, so this is notes. For video lesson 19. I wrote this up here and I think I'm going to change one of them. Let's see here, we have the fundamental counting rules. You know what? I am going to change it. I'm going to take off 17 and 18. So there's a new textbook handout. Okay? It's going to be pages 253 to 235. I'm sorry, 233 to 235. And I only want you to do 1, 5, and 8 for homework. Easy like Sunday morning. Okay? So let's get through a couple of examples and then you can just jump into the homework. All right? So we have a coin is tossed and a die is rolled. Find the number of outcomes for the sequence of events. You could draw a tree diagram. You can just write the sample space. It's totally up to you. So a coin, the coin. A coin can be heads or it could be tails. So I can throw a coin, it can land on heads, and then over here I can have my die. Okay, your die has 6 sides. 1, 2, 3, 4, 5, 6. Okay? So it could be a heads and a 1, a heads and a 2, a heads and a 3, a heads and a 4, a heads and a 5, heads and a 6. You can write it that way if you want it. Heads 1, heads 2, heads 3, heads 4, heads 5, heads 6. I hear her little cute voice. It's so adorable. Okay, same thing with tails. It could be a tails and a 1, 2, 3, 4, 5, 6. So it could be a tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. So, number of outcomes. How many total outcomes in the sample space? 12. Oh my God, her little voice is so cute. 12 outcomes. Okay? Or, by the counting principle, the counting rule, for heads or tails for the coin, there's 2 possible outcomes, heads or tails, and means you multiply. How many possible outcomes for a die? There's 6. What's 2 times 6? There's 12. Okay, that's your fundamental counting rule. So let's write that down. In a sequence of events in which the first event has k possibilities, and the second event has m possibilities, the total number of possibilities of the sequence is, you multiply them, k times m, because it's both of them. Hi, boo-boo. Good morning, boo-boo. Good morning. Oh, she's going to give you the pacifier. Get over here. Hi, princess. Can I have a good morning kiss? Yeah. Mwah. Good morning, baby.
Good morning.
Can I have a hug?
Yeah. Oh, she's so sweet. She's such a sweet girl. Oh, thank you for the hugs. How'd you sleep?
Good.
Just good?
Yeah.
Yeah, you look like a princess.
What my arms do?
What does your arm do? What's wrong with your arm?
My fancy things go on this.
Oh.
Fancy Nancy goes on that.
What do you mean? Up in clouds. I see you. Wow.
You see clouds.
Where's the clouds go?
It's a little cloudy today, right?
Now it's all clouds, so it looks white, Ophelia. That's still clouds up there.
Sorry, guys.
It was yesterday.
You're getting my good morning with Ophelia. Come here. Come
It's
here.
supposed to rain today or something?
No, it's just supposed to be overcast, cloudy like this. Hi, Boo Boo.
Hi, Mama.
I love you.
Can I take my pacifier out?
Can you take your pacifier out? Yeah, you can put your pacifier back in. You wave to my students. Go like this. Go hi.
Hi.
I know they want to see you right now. But if I take the camera down, it's going to be a whole big problem.
Hi, Clark.
You want to draw with Mommy? Okay. All right, looks like I'm going to have an assistant, guys. Can you handle it?
You want to watch Fancy Nancy on TV, Ophelia?
Do you want to watch Fancy Nancy? You want to watch Fancy Nancy?
Yeah.
Okay. All right, go watch Fancy Nancy. Hey, yeah, you. Go watch. I'll be there in a few minutes, okay?
I found this remote over in the window.
Okay. I wonder if that was the stasher or Olivia.
I'm sorry. I'm sorry.
Oh my God, you just crushed the cat.
Sat right on it.
That's terrible. Jimmy just killed one of our cats. Our animals are like camouflaged into the couch though, so it's not his fault.
2 of the 3 animals are the same exact color.
They look exactly like the couches. So when the little one sits on the couch, the cat, it's
And the other one is black, so he blends in any with shadow or anything.
yep, that's the one that was laying all over my stuff
Doesn't
before.
socialize.
Okay, so types of paint. A paint manufacturer wishes to manufacture several different paints. The categories include, so you have color, type, texture, use. You have 1, 2, 3, 4, 5, 6, 7 different colors. 2 different types, latex or oil. Latex is usually shinier. You want to use that in bathrooms and kitchens because you want to be able to wipe it more often. I'm sorry, that's texture. Texture is flat, semi-gloss, or high gloss. High gloss you usually use in bathrooms or kitchens. Flat you usually use in bedrooms. And then use is outdoor and indoor. So we have 3 of these and 2 of those. How many different kinds of paint can be made if you can select 1 color, 1 type, 1 texture, and 1 use, which is exactly how you order paint when you go. Well, if you think about color, there are 7 colors. And means you multiply. How many types? 2 of them. And means you multiply. How many textures? 3 of them. Jimmy, that's really loud. And means you multiply. Loud. You're gonna wake up Olivia. I don't care about this. I'm just worried about waking up Olivia. And the use is 2 of them. So if we multiply, 7 times 2 is 14. 14 times 3 is, I think, 42 and 44. Let's see. How did I suck so bad? 14 and 14 is 28. 32, 42, 44. 7 times 2 times 3 times 2. How am I off so much? 6, 12. It is 84. I should have went the other way. I don't know, guys. I suck. So we have 84, okay? The counting principle is pretty basic. You just multiply. It's pretty basic till they get to weird ones. Let's take a look at some of them. There are 4 blood types, A, B, and O. Blood can also be Rh positive or Rh negative. Finally, a blood donor can be classified as male or female. So when they take your blood type, they look at A, B, or O. They look at if you're Rh positive or Rh negative, and then they also do it by female or male. How many different ways can a donor have his or her blood labeled? Okay, so when you look at how many different ways they can have it labeled, you got to think of, first you have your type, okay? How many different blood types are there? 1, 2, 3, 4. And you can be positive or negative. That's 2 of them. And means you multiply. You can be male or female. That's 2 of them. So it looks like 16 total. Okay. And then last but not least, and we'll wrap it up and do permutations and combinations next lesson. Identification cards. The manager of a department store chain wishes to make 4-digit identification cards. Okay, so they're going to be 4 digits. How many different cards we made if she uses the digits 1, 2, 3, 4, 5, and 6, and repeats are allowed. Repetitions are permitted, so you can repeat the numbers, okay? So there's how many total you can repeat, which means I can have the number 1, 1, 1, 1. I can have the number 6, 6, 6, 6. I can have the number 4, 4, 4, 4. You understand what I'm saying? Repeats are allowed. So how many total numbers can I put for the first digit? 1, 2, 3, 4, 5. That's right, 6 numbers. And I can use all 6 again. And I can still use all 6 numbers. You're allowed to have repeats. And I could still use all 6 numbers.
What's that?
So that's 6 to the 4th power. That's 1296. Now, what if you can have no repetitions, no repeats? What if I change the question? Still a 4-digit ID, but no repeats allowed. That means I start out having 6 numbers, but then every time I use a number, I lose a number. So say I use the number 1. Now I only have 5 numbers left to choose from. Then I use the number 4. Now I only have 4 numbers left to choose from. Then I use the number 3. Now I have 3 numbers left to choose from. You see what I'm saying? So it's a game changer. You have to be careful. So 6 times 5 times 4 times 3 is 360. Big difference. So if I'm a manager of a store, you want to be careful which way you tell somebody to set up random ID numbers for your employees, because if you have a big store, you want to make sure you allow repeats so that there's more possibilities. As opposed to a smaller store or smaller chain, they don't have to worry. They can have numbers, no repeats allowed, okay? So that's a big difference. Think about school district like William Floyd with our ID numbers, and we'll leave you off on this one. You think they allow repeats or don't allow repeats for William Floyd School District for our ID numbers? That's how we punch in, punch out. It's attached to our payroll, our check. Damn straight they allowed repeats because we have so many staff members that work for the William Floyd School District K through 12. They have to allow repeats. They have to have more outcomes, okay? Just something to think about. All right, so homework, I'm gonna go back to it and then we'll call it quits. You're going to do, in the text, new textbook handout, page 233 to 235, you're gonna do 1, 5, and 8. Just 1, 5, and 8. So if you take a look here, you have 1 on zip codes, and there's 2 questions, so there should be 2 answers. 5, okay, and then 8. And it looks like there's 2 questions for 8. So 1, 5, and 8, give them a try. Be careful of repeats and non-repeats, and I will see you at lesson 20. Take care. Brush your goddamn hair.